I have a question for you. Are you preparing for UTME exam? This class is for you. It's kind of sort of study, and then you are given an area to study. It's kind of telling you, move to this side, study this side. This is what to pay attention to. That's what we're looking at today. You look at the topic, the JAM/UTME concept of chemical compound. Now, you already know that chemical compound is the combination of different atoms of elements. And these different atoms of elements are combined chemically in a definite proportion. So it will form a compound. The arrangement is that atoms of elements, group of atoms of elements forms a compound. Where you can also continue and say we now have matter, which can be called substance. Anyway, this is a general definition of compound. Compounds are a group of atoms of elements that are chemically combined together in a definite proportion. Now, but the UTME expects you to know the classification of compound. That's what their questions, or where they pick their questions from. Then we're going to be considering it, the classification of the compounds. The classification of compound. Remember, chemical compound, not the compound in your house. I hope you know that. Chemical compound. Alright, now, the classification is based on the following. The classification is based on the following. Number A is based on the behavior. The behavior when exposed to the atmosphere. Behavior when exposed to the atmosphere. Number B is the nature and the properties. The nature and the properties. Number C is the source of the compound. Now we're going to take up the first one, based on the behavior of the compound when exposed to the atmosphere. Well, there are three major definite behavior characteristics of this compound when exposed to the atmosphere. Number one is that there will be the liquescent. Number two is there will be hygroscopic. Number three is there will be efflorescent. And then number four is there will be effervescent. Okay? Now, either it is, sorry for you. Okay, effervescent. Either it is the liquescent, hygroscopic, efflorescent, or effervescent. Whichever one it is, they have different characteristics when exposed to the atmosphere. For instance, the liquescent substance forms a solution when exposed to the atmosphere. And then the judge will ask you a question, which of these compounds forms a solution when exposed to the atmosphere? And then they say option A, the liquescent, option B, hygroscopic, option D, efflorescent, option, whatever they have there, effervescent. The answer is the liquescent. It's the liquescent substances that form solution when exposed to the atmosphere. Then we have to know the examples of the liquescent. The example, you know that the liquescent is not the same thing as the liquescent. The liquescent is not the same thing as the liquescent. The liquescent is the compound itself. The liquescent is the process of this compound forming a solution when exposed to the atmosphere. Then the example now, their example is the sodium chloride, the iron chloride, the calcium chloride, I lost my chop now, the magnesium chloride. Now you will say, oh, since it's adding chloride to all of them, that means that all chloride compound is hygroscopic, is like the liquescent. Because hydrogen chloride, sodium chloride, fluorine chloride, calcium chloride, magnesium chloride. So all chlorine compound is the liquid set. No, it's not at all. It's not that. Then, be careful. We have potassium hydroxide. We have sodium triosonitrate. So these are examples of the liquid set substance. We have phosphorus pentaoxide. So these are examples of the liquid set substance. Meanwhile, we go to the next one, which is hygroscopic substance. So one jam will ask you, they can list for you, which of these is a deliquescent substance? Which of these is a deliquescent compound? They can write for you something like this. And then they say option B, and then they put sodium chloride. They will say, which of these is a deliquescent substance? And then you have these two options. We don't have much time, but I'll give you more options. The answer is option B. Option B is one form solution where it is exposed to the atmosphere. Are you still with me? Stay with me. Stay with me. Now we go to the next one, which is hygroscopy. Hygroscopy becomes wet or becomes moisture when exposed to the atmosphere. They're either wet or they are moisture. Now, for the hygroscopic substance, I will need to take up these. When we need it, we're going to bring it back. I will need to take up these and then use here to give you some examples. The examples of these guys is the H2SO4, the sodium transnitrate, the potassium hydroxide. Now, notice that sodium transnitrate, potassium hydroxide, that is called caustic potash. And then over there, in fact, we have a video where we discuss compounds like caustic potash, sodium, caustic potash, caustic soda, washing soda, slake lime, soda lime, and we have to talk about the reactions with water and how JAM derives questions from those compounds. You need to wait for that video, if you will. So we now know that these two compounds, are you still with me? They are deliquescent. They are hygroscopic. Why? That's the question. It means that hygroscopic can be equal to deliquescent. It means that an hygroscopic substance can eventually become a deliquescent substance, but a deliquescent substance it will never be an hygroscopic substance. You know why? If you take, for instance, have you played when you're little? You take some mold, some mud, and then you try to add water to it, and then mix the thing with water. Do you notice that when you mix a little water, it becomes wet and moisture? Are you with it now? Now, when you add a lot of water to it, it becomes too much, it becomes a solution. Now, it means that you cannot start from solution to that mud, but you can start from mud from that moisture to solution. It can be a moisture to solution, not solution to moisture. That's what is happening here. So this potassium hydroxide can become a mixture and then form a solution that is deliquescent and also be hygroscopic. Are you still with me? Another example of hygroscopy is copper oxide, and then this guy is my friend. I love him so much. You know what? It's a jam question. It's called the quicklime. That is calcium oxide. Quicklime is the guy that is used in drying ammonia. It is the suitable guy that dries ammonia. Take this. It's coming out. It's coming out to the exam. Take it. It's coming out. It asks you that the compound that is suitable for drying ammonia, the name is calcium hydroxide, or it's also called the quicklime. All right? It's coming out. All right? Now let's continue. Now we want to go to the next thing. Mind you, hygroscopic and deliquescent substance are used as drying agents, the two of them. So we're going to the next one, which is the efflorescent. The efflorescent. So what does it mean by efflorescent? Efflorescent, let me write down the word. Efflorescent. Okay, what does it mean by efflorescent? Now, for a substance to be efflorescent, it means that it has the ability to lose water molecule when exposed to the it has the ability to lose the water molecule when exposed to the atmosphere. Now, what that means, some of the compound that does that is the sodium transcarbonate pentahydrate. Now, this guy lose all its water molecule and become sodium transcarbonate monohydrate, that is H2O. Okay? Now you can see that the 10 water molecule is lost, and then eventually you have a water molecule. Now, efflorescent compound, efflorescent are substances that lose water molecule when exposed to the atmosphere. So we have the next one. Let's use another example. Sodium tetraoxosulfate decahydrate. Alright? Okay, I say, how did he get all these things? Well, there's a video, if you will, you can ask us for it, drop the comment section, we'll tell you how to get to it, which will discuss how to make any kind of chemical compound. Are you still with me? Still. So this guy becomes an hydrous salt, an androus salt. That means it lost all the water molecules. So it will have sodium, SO4, and then H2O. Then the next guy is effervescent. Okay? Effervescent. Put up the board now. So this effervescent substance, there are substances that have you drunk a carbonated drink before? That is, you have drunk a carbonated drink, but if you are drinking alcohol, I would advise you to stop. Alright? I would advise you to stop for your health's sake and minimize that, or stop it eventually. That's why. Now, effervescent, when you open that, whatever is carbonated drink, you open it, it loses some gas. So that fusy gas that is losing is the process that is known as effervescent. So it's the loss of gaseous molecule. But don't criticize me, drinking is bad for your health. Alright? Anyhow, so we are going to the next thing. The next thing is to know that hygroscopic and the lubricants are used as drying agents. So we can divide the board. We can divide the board, and then right here, drying agent. And then we write the gases, they dry. Now, H2SO4 is the first one. H2SO4 dries all gases. All gases except ammonia. Then, let's we need space. We need space. Get out of here. Get out of here. Get out of here. We need space. Okay? Then, hydrogen sulfide. Then, hydrogen bromide. Alright? Now, another guy is calcium chloride. Calcium chloride dries all gases except ammonia. Now, see what jam will ask you. We are talking about concepts of jam. See, look at this. I'll give you the whole. H2SO4 dries all gases except ammonia, and then they give you other gases. You see that now? H2SO4 can dry all gases except ammonia. If you see ammonia in the option, that is the answer. If you see hydrogen sulfide in the option, that's the answer. If you see hydrogen bromide in the option, that's the answer. That's the gases that H2SO4 does not dry. Now, calcium chloride dries all gases apart from ammonia. Then another guy is phosphorus pentaoxide. This guy also dries all gases apart from ammonia. Yeah? Which guy dries ammonia? If you have followed us from the beginning of this course, I told you something that I love the guy. That guy is called calcium oxide. CaO. It's also called nuclide. So this guy dries, in fact, most of the textbooks put it suitable for ammonia. Is suitable for ammonia. Now, this is where the questions come from. We're talking about the concept which is expecting you to focus your attention to, because that's where the question is coming from. Number one is to know that compounds are classified in 3 bases. Number one, as behavior of compound when they're supposed to be atmospheric. Number two is the properties and their nature. That's what we're talking about. The next thing is the properties and the nature. Alright? The properties and the nature. Now we go back to the nature and the properties. Alright? So from A, acid. Let's not waste time. When the compound is an acid, it contains hydrogen ion. So help me, what is this? H2SO4, hydrogen tetraoxide acid is an acid. I even say acid. Another one, HNO3, that's an acid. Hydrogen trioxide. You can calculate the oxidation number to find the 5 like that. Okay? Now, give me another one. HCl, that's an acid. But if a compound is a base, it has hydroxyl. Compound have hydroxyl, sodium hydroxide, potassium hydroxide, and so on and so forth. Those guys are base. The presence of hydroxyl, this hydroxyl makes it a base. Now we have a salt. We have sodium chloride salt. We have sodium tetrahydrosulfate 6 salts. So all these things are salts. Let me show you. How a salt is formed is when you have an acid plus a base. Okay, when acid like HCl combined with a base like sodium chloride, like sodium hydroxide, we should have sodium chloride plus water. So acid combines with base to form salt and then water. So the salt is a compound. And one of the classification of compound is contained because of nature and properties. When we talk about salt, and we talk about it as a nature property of a compound. And we have other salts. We have sodium tetraoxide acid. You can check out the way it's formed in our previous videos of reactions. Alright. Now we have the last one. Based on source of the compound. Now the source now, it can be organic, it can be inorganic. Now, when a compound is organic, it means the compound is gotten from living things, plant and animal. The methane, the propane, any organic compound that is gotten, that when a compound is organic, it's gotten from living organism, plant and animal. When a compound is inorganic, it's gotten from mineral salt and the rest of them. I believe this video will help you. Remember, for the summary, John asks you questions based on the characteristics of compound. They want you to know, 1, their behavior when exposed to the atmosphere, 2, their properties, that their behavior is luminescent, hygroscopic, fluorescent, effervescent. Their nature and properties, that is, whether it's an acid, whether it's a base, whether it's a salt. Okay, that means you have to also study salt. Then the third one is the source, organic and inorganic. Alright? So, and then we have another video where we talk about these, some of the compounds. I told you some major compound jam stress questions on is caustic soda. We'll talk about the formula and everything you need to know. The washing soda, the snake lime, the pink lime, and the rest of them. Alright? So is there a lot? About 7 of them. And we even the one they call the Epsom or something. I think it's Epsom or Epsom. Epsom. Okay, let me give you the formula. The formula is this. Magnesium SO4 and H2O. Something like this. Alright? So these are the stuffs that we'll be looking at in that video. So if this video has helped you, we'll see you in the next class. Thank you.